So in this lesson, we're going to determine holes. I know we've already talked about holes a little bit, but there's one more thing we have to talk about for AP. And then use limit notation to describe function behavior near holes of graphs. So let f of x equal g of x over h of x be a rational function. The graph of f of x has holes where there are common factors in both the numerator and the denominator. Where the factors have multiplicity in the numerator that are greater than or equal to the multiplicity in the denominator. So before we move on, I want to make sure you guys understand this because this is super important. You guys had a homework problem that was kind of like this where you guys were given information from 1.9. The very last question, you guys know what I'm talking about, where it didn't give you guys the equation, but you guys had to kind of like answer questions about the graph. Okay, so let's say you guys have a problem. So let's say it's like x plus 2 times x plus 1. You guys can just watch for now. All over x plus 2 squared. So do you guys see how there's a, don't write this down, just watch. Do you guys see how there's a common factor of x plus 2 on top and bottom? Okay, so do you guys agree that means that I could cancel this and cancel one of these, right? So then I'm left with what? X plus 1 over x plus 2. So normally we would say that there's a hole, right? But I still have an x plus 2 on the bottom, which means what about the graph? There's what right there? Vertical asymptote. You can't have a vertical asymptote and a hole at the same time at the same number, okay? So if you guys look at this definition, do you guys see how it says the multiplicity in the numerator is greater than or equal to? In this problem at the beginning, where was the power bigger, on top or bottom? Bottom. So that's why that definition is important, because if this was, so let me go backwards and erase this. If I were to write squared up top, that means that this would cancel and this would cancel, and I'd be just left with x plus 2, right? Yeah. Times x plus 1, where because one of these canceled with this, that means there is a hole there. That's the difference, okay? All right, so let's do a couple problems. So what I want to do is I want us to identify first, where are there holes on the graph? So at what x value does it look like there's a hole? 3. So x is equal to 3, okay? Now, on this graph in particular, since we can see it, does it look like, guys, to you that the hole is at the point 3, 1? Okay? So just like we did for asymptotes, we can also use limits to describe holes. So using limit notation, this is how we're going to do it. So if I'm on this side of 3 going towards the hole, so this is the left side of 3, the limit as x approaches 3 from the left of our function is equal to, on the left side of 3, if I get really, really, really close to the hole, what is the y value getting close to? 1. So the limit as x approaches 3 from the left of this function is equal to 1. So as x approaches 3 from the left, f of x is approaching 1. And then on the right side of 3, my bad. On the right side of 3, the limit as x approaches 3 from the right of f of x is equal to, so do you guys agree this is the right side of 3? So if I'm getting close to 3 from the right side, what's the y value getting close to? It's also 1. So as x approaches 3 from the right, f of x also approaches 1. So this is how you know that there's a hole. Because on both sides of 3, do you guys see how we have the same y value? That means that represents a hole, okay? Okay. Questions on that? You won't have to write this unless the problem like asks you to, but I just want you guys to understand like this means that, okay? All right, so calculator question. I know on your guys' paper it's kind of small, but I was trying to make it so everything fit. So sorry if it's hard to see. I can zoom in here. Okay. So here, before we do anything, one thing I could do is factor. So on top, what could I factor out of the top? A 10. So this is equal to 10 times what? X plus 3, good. And on the bottom, does it factor? Thank you. Does it factor? What does it factor to? Good. You guys notice anything? Yes. I'm shocked. You guys shocked? I'm so shocked. Those cancel. So what does that represent in the graph? A hole. So what's left on top? 10. And what's left on the bottom? X minus 2. So if we were to graph this crazy thing, this is what we'd be graphing. Okay? Now, because we know this, do you guys see how we were able to cancel the x plus 3 to get this? So if you guys were to use a table feature in your calculator, the way that this is written, if you use this function or if you use this function, you should get the same numbers, okay? But notice that we're actually not plugging in -3, we're plugging in numbers that are really close to -3. So what I want you guys to do to practice this is I want you guys to open up the table and I want you guys to tell your calculator what you're plugging in. So type this into Y1 and I want you guys to test some values. So practice doing this because this is important. And if you guys need help, raise your hand. Okay, are we getting numbers? Yeah? Okay. So if I were to randomly call on you guys would have answers for me? Now you guys look panicked. Okay, so this is what I get. I get negative 1.961, negative 1.996, and then did your calculator just tell you negative 2?
Yeah.
Okay, that's weird. And then negative 2 again. So what this actually means is this is so close to negative 3 that your calculator is like, nah, that's negative 2. That's what that means, okay? All right, on the other side, do you guys need time to do the other side, or do you guys have the other side too? You guys have it? Okay. Negative 2.041. And then negative 2.004. And then negative 2, negative 2. Okay. So what this means is this is the left, right? So if we figure this out with our calculator, the way we'd write it using a limit is you would say the limit as x approaches negative 3 from the left, and then careful, this time our function is g of x is equal to negative 2, because as I pick numbers that are smaller than negative 3 and get closer and closer, my calculator gets really close to negative 2. The limit as x approaches negative 3 from the right of g of x, same thing from the table, is negative 2. So because these answers match, we know that there's what in the graph? A hole at the point, what? Careful, what is this getting really close to? So negative 3, comma, negative 2. Okay, we also could get negative 2, do you guys agree, from plugging in negative 3? If we plugged in negative 3, just like you guys were taught in math 3, into this function, you would get negative 2. So I hope that's kind of cool in the fact that all of these ideas are related to each other on why this is true, okay? All right, so we're going to draw a really rough sketch of this. So at the point negative 3, negative 2, I'm going to draw a hole. So look at our simplified function, guys. Is there an x on top? No. So remember, the zeros of the function are where the top equals 0. The top is just 10. Is 10 ever 0? No. So there's no zeros. Y-intercept. If I plug in 0, 0 minus 2 is negative 2. What's 10 divided by negative 2? Negative 5. So 1, 2, 3, 4, 5. Y-intercept is negative 5. Is there a vertical asymptote? Yes? Where? X equals 2? Now, look at your simplified function, guys. Where is the power bigger, top or bottom? Bottom. So that means, do we have a ha? Yes. That was a delayed reaction. Yes. Where? 0. Good. Okay, here's another that's going to look really tacky. Story connected. Story is beautiful because everything is tied together. I just told you guys there's no zeros, right? What do we have at x equals 0? a horizontal asymptote. Those ideas are connected because there's no zeros, okay? So that means that a rough sketch is going to look something like this. And something like that. Okay, questions? No? Okay. Please don't be shy, guys, if you guys need help with the calculator stuff, because I feel like sometimes kids, I mean, you guys feel scared to say they need help with the calculator because it seems easy to use a calculator. I need you guys to be really good with your calculator. So if you guys need help with anything, how to do something, let me know. Okay. Special case. So I'm going to give you guys g of x equals I just realized you guys are frantically taping, so I'll pause. Your sweater's wet, dude.
I was standing at PHS for like 20 minutes because it was really
Nice.
my back.
Is that where you live? Over there?
I live in Brooklyn.
Oh, wow. All right, so we got x minus 1 times negative x squared plus 2x plus 4 all over x minus 1. All right. So not a trick question. Do you guys know something? What? There's a hole where? X equals 1. Good. So these are same power or different powers? Same power, right? So that means there's going to be a hole. Now, what's left on the bottom? 1. Good. 1. Not 0, right? 1. And then on top, I'm left with this. So g of x is just equal to negative x squared plus 2x plus 4. Hey, guys. What type of graph is that? Quadratic, which is what shape? This is a U-shaped graph. So something that we've talked about in Math 2 and Math 3, but with a hole. All right. Now, you guys have your calculators, but I just want to refresh your memories in case you guys need to graph something like this by hand. This is in standard form. So you guys remember A, B, and C? To find the vertex, you have to do negative b over 2a. Does that sound familiar? Okay, so the axis of symmetry, x equals negative b over 2a. What's b in this problem? 2 all over 2 times, what's a? Negative 1. So we get negative 2 over, what's 2 times negative 1? Negative 2. What's negative 2 divided by negative 2? 1. That's weird. Why is this a weird answer with what we've seen so far? Because we already have a hole there. That's weird. So to find the hole, just like normal, what do I do with this number? Plug it into the equation. So in this case, guys, This is our axis of symmetry, right? So x equals 1. Do you guys remember you guys would draw like a dotted line through the parabola? What this means is whatever the vertex is, that's also the hole in this case. That's really weird. So to get the answer, I need to plug this into my original function. So g of 1 is going to be negative 1 squared plus 2 times 1 plus 4. PEMDAS. So you're going to do the power first. 1 squared is just 1. But let's make it negative. So negative 1 plus 2 times 1 is 2 plus 4. Negative 1 plus 2 is 1 plus 4 gives me 5. Okay? So the vertex, which in this case is also the hole, is at the point 1 comma 5. Okay, now I'm going to be super lazy. In math 3, you guys would make a table, right? I don't want to do that. So if I know my function, to find the y-intercept, do you guys remember I can just plug in 0? So I plug in 0 into this, I get 0 plus 4. So I know that this graph is going to have a y-intercept at 4. And then axis of symmetry, this is the axis of symmetry, right? How far away from the axis of symmetry is this point right here? One, right? So from the AOS, that means I could reflect and get another point across. So I have another point right there. Okay? So this graph is going to look something like this. Something like that. It's a crazy world. Now, you guys won't have to do anything like this like on the AP test. I'm just showing you guys like this is possible. Okay. Last problem. Do you guys have any questions on what I did? No? All right, last problem. So let's look at h of x is equal to x minus 2 squared over x squared plus 4x minus 12. Before I do anything, guys, what should I do first? Factor. Okay, so the top is already factored. This is x minus 2 times x minus 2. The bottom, though, what could I factor the bottom to? Good. X plus 6, x minus 2. Okay. So do I have a common factor? I do. Where is the multiplicity greater, top or bottom? Top. So from our definition, since the multiplicity is greater on top, that means what? There's a hole, okay? So there's a hole. So this will cancel with one of these. So I'm left with a single x minus 2 up top and then an x plus 6 on the bottom. Okay? All right, so domain. So the domain means wherever what is 0, top or bottom? Bottom. So before this canceled, guys, what makes the bottom 0 right there? 2. And then negative 6. So the domain's going to be all real numbers except those values. So we have to skip over those. So the domain is going to be negative infinity to negative 6, union, negative 6 to 2, union 2 to infinity. Where's the hole at? X equals 2. Now to find the point, guys, remember that means I can just take this number and plug it into my simplified function. Okay? But notice that if I plug it in, what is 2 minus 2? 0. On the bottom, you'll get 2 plus 6, which is 8. 0 divided by 8 is 0. So the hole is going to be at the point 2, 0. All right, so this is a tricky one. To find the zeros, what we learned is, remember, you set the top equal to 0. If I set this equal to 0, do you guys agree we get 2? But the issue is, what do we know already exists at 2? A hole. It can't be both a 0 and a hole at the same time. So since it's already a hole, that means there are no other zeros. So here there's none. Okay, vertical asymptotes. Where do I look, guys? The top or bottom? The bottom. Vertical asymptotes look at the bottom. What makes the bottom 0? -6. So the vertical asymptote is x equals -6. Horizontal asymptote. We look at what, guys? The degrees. What's the degree on top? 1. What's the degree on the bottom? 1. What do? Divide the leading coefficient. So 1 divided by 1 gives me 1. Good, guys. All right. So now it's kind of like tying everything together. Last question. So end behavior, that means as x gets really big or x gets really negative. So the limit as x goes to infinity of g of x is equal to, when you guys were doing the whiteboards yesterday or Friday, I can't remember which day, you guys saw this problem, but what I was trying to tell you guys is if you guys know the horizontal asymptote, that gives you the answer to this. So does this graph have a horizontal asymptote? It does. So as x gets really large, what does this graph get really close to? 1, okay? And then the limit as x goes to negative infinity of g of x is also going to be 1.